Okay, something a little bit different today. So we've got an email from the government, the transition to flexible and remote learning, and I'm going to be talking about the things that are pertinent to us in further maths and as VCE students. So all of you guys are going to be learning from home unless you're in one of these three groups, or if we tell you that you need to come to school to satisfy a learning task or learning outcome, then you'll also need to come to school. So that's specifically for VCE and VCAL students. I'm not going to say this is going to happen for further maths, but if you're at risk and you need to authenticate a task or this or that, then you might have to come to school. So we can still ask you guys to come to school. Obviously, we do have to adhere to the physical distancing and hygiene measures that are given by the government anyway. So the learning program, if you are at school, is going to be the exact same one as the one that's going to be at home. So for us, that's our videos and the Edrolo content. Also, you guys already have your Unit 3 outline, but that is our schedule or calendar that shows what you guys will be expected to do in terms of learning tasks. We'll also give you a sort of a calendar of when the tests and SACs are going to be. So just keep an eye out for that. This part here is just saying that you guys are doing the full VCE study design for all of your courses. So if anyone was considering whether or not they were doing sort of a reduced load or something like that, apparently not. You guys are going to be doing the full study design, same as what it would have been for any year. And I understand that it is difficult and trying circumstances for all of us, but we're all suffering through the same thing. So bear with us, chin up, and just do what you can. That's all from this document that I wanted to talk about. Let's get into today's lesson, which is looking at nominal and effective interest rates. This is chapter 5F in Edrolo. And these two words, nominal and effective, we're going to hopefully have some sort of an idea of by the end of this lesson. But first, let's look at this question, which is hopefully something that you guys still remember from last lesson, from 5E. So this is from the 2013 exam. David keeps deer on the farm. He plans to increase the number of deer each year. The number of deer on the farm each year will form the terms of a geometric sequence with a common ratio of 1.5. So that means our capital R is 1.5. David began with 32 deer on the farm. Why don't we do something different and call this D0? So 32 is D0, rather than using V0. We're representing deer. Deer starts with D, so why not use D0 instead of V0? Here it's saying, write an expression in terms of n. So an expression in terms of n that can be used to predict the number of deer on the farm after n years. So predicting the number of deer on the farm, we're asking for an expression in terms of n, which means that we're asking for a rule for the nth term. Notice that it's not here saying anything about recurrence relation. We're asking for a rule for the nth term. If we look at our notes, our rule for the nth term is Vn equals r to the power of n times V naught. So I'm going to write it a little differently using d instead of v, equals r to the power of n times V naught. So we just have to substitute values in for r and V naught, and then we've got our rule for the nth term. So we can write dn, the number of deer at time n, equals 1.5 to the power of n, 1.5 is r, times d naught, which is 32. And I just realized, and you guys might have realized as well, even though I made a big deal about using d, I use v instead. Anyway, that's your mark for this question. That is the rule for the nth term to figure out the number of deer after n years. So for example, if we wanted to figure out the number of deer after 100 years, we would write d of 100 equals 1.5 to the power of 100 times 32. So that's sort of how you use this rule for the nth term. Okay, but nominal interest rates, we're looking at something a bit different. Okay, cut that. All right, so what are nominal interest rates? So remember that compound interest rates are usually quoted as annual rates or interest rates per annum. This rate is called the nominal interest rate. Okay, let's make that a bit more concrete. The terms of the compound interest rate, interest loan or investment are usually quoted as a nominal interest rate followed by a compounding period. So you might see something like 5.2% per annum compounded weekly. So in that case, that means our weekly rate would be 5.2 divided by 52, which is 0.1% per week. And so far, that's how we've done it. Now, the nominal part is just this section. So the nominal rate in this case is 5.2% per annum. The compounding period is weekly, and you should know that weekly means n equals 52 because there's 52 weeks in a year. So if we're thinking about effective interest rates, we have to look at the general principle that with compound interest, the more frequently interest is calculated and added, the more rapidly the value of your investment or loan increases. I think a really good way of looking at this is just to do it in your calculator. So let's say we have $500 and we're going to do that at 5% interest rate for a year. So 1.05. Let's do it the long way. 1 plus 5 over 100 to the power of the number of compounding periods, which in this case is just 1. So after a year, we've got $525. What if we did our compounding periods of a monthly compounding? Instead, we'd have 1 plus 5 over 12 over 100, but we do it to the power of 12. So in this case, we've got $525.58. So just by changing the number of compounding periods, we've increased the amount of money, albeit by a small amount, only 58 cents. But if we do daily as well, 1 plus 5 divided by 365 divided by 100, and then we do this to the power of 365, again, we see an increase in the value that we get after a year. So 63 cents rather than 58 cents. And while this might not seem like a large amount, over time, this adds up. So that's the idea. Smaller compounding periods, so more compounding periods per year, means that you get a higher value at the end of that year. Now, we want to be able to compare between interest rates, between nominal interest rates. And the way we do that is by converting it to an effective interest rate for the year. So our effective is the effective annual interest rate. So that's like converting if we have 5.2% per annum compounded weekly, and this is our nominal interest rate, then our effective interest rate is what this whole thing would be, this 5.2% per annum compounded weekly. What would it be per year if it was just compounding once a year? And this is our formula for that. So this is a pretty ugly looking formula, I think you'll agree. And there's brackets everywhere and it's sort of a bit confusing. But most of the time you won't have to use this, and I'll show you why in a second. But please write this down in your notes, and I've actually written it across both geometric growth and decay because we're looking at compound interest. It is geometric. So I've written it across both columns, and I want you to also write or EFF bracket R comma N close bracket in your CAS, because that's our alternate way of calculating this. And I would argue a way better way than actually putting things into this formula. So why do we care? If we want to compare two interest rates, and they do have different compounding periods, the way we do that is by comparing their effective rates. So you can't just say 5.3% per annum compounded monthly is more than 5.2% per annum compounded weekly. You don't know that because the compounding periods actually make a difference on how the value of the investment changes. Let's look at an example. Brooke wants to borrow 20 grand. She's deciding between two loan options. Option A is 5.95% compounding weekly. Option B is 6% per annum compounding quarterly. So let's calculate the effective rate for each investment. For option A, we're looking at 1 plus 5.95 over 52, which is, that rate divided by 52 weekly, divided by 100, to the power of 52, and then all of that minus 1, and then all of that times 100. And you end up getting 6.12%. For option B, we've got 1 plus 6 divided by compounding quarterly, so we divided by 4 over 100 to the power of 4, so these two numbers are always going to be the same, minus 1 times 100, and that gives us 6.13%. All right, these are our effective rates, 6.12 and 6.13. Now, which option is best and why? So remember that option A was 6.12% and option B was 6.13%. Now, Brooke is borrowing $20,000. This means that she wants a lower rate, so she has lower repayments and a lower amount that she owes at the end. So in this case, option A is better. But if she was lending this out, she would want a higher rate so that she gets more repayments to her. So in this case, deciding which option is best depends on which side of the equation you're on. Are you a lender or are you a borrower? So please don't forget to consider that in these types of questions. Marissa has 10 grand to invest. She chooses an account that will earn compounding interest at a rate of 4.5% per annum, compounding monthly. So that means our nominal rate, R, is 4.5, and compounding monthly, our N, is 12. Use a CAS calculator to find the effective rate for this investment. Correct to 3 decimal places. All right, so this is what we were talking about before, our effective rate. You can do this in 2 different ways. Menu 852 gives you this effective EFF open bracket. I think it's also just as easy to type EFF, and why have I got caps lock here? EFF open bracket. It's the same thing. What you need to put is 4.5 for the rate, comma, 12 for the number of compounding periods, and then we have it. No need to type it into a big ugly formula. We instead just have 4.594 to 3 decimal places. So REFF equals 4.594% per annum. Okay, today's work is chapter 5F, questions 1 to 6, and then questions 11 to 13. These are from previous topics, and I really encourage you guys to do those ones as well, because I don't want that knowledge to fall out of your head from having no practice of it. So please do all those questions. If you have any questions for me, chuck me an email, send me something on Teams, however you want to contact me. And yeah, good luck.